Welcome folks. Before us we have a question in physics under Newton's second law of motion. The question reads, Figure B 2.1 shows some of the forces acting on a car of mass 800 kilograms. Now we will have a moving car with a direction showing that this car is moving to the left. Now we have a driving force. So if you look at a driving force, this is the force produced by the engine that is making the car to move. Then we have another force opposing this motion, which is a total drag force. Now, if you look at question A, we are taught to state the size of the total drag force. So we want to find the force that was opposing the driving force when the car is traveling at constant speed. Now, how do you answer a question like this? So what is the key to knowing of the total drag force? So the key will be gotten from this point of constant speed. In some texts or maybe question, you might find this as constant velocity. Now, if we are to understand it fully, there is a difference between speed and velocity, but let's not focus on that. So now, when the vehicle is moving at a constant speed, what are we supposed to know? So the first one, we are saying the velocity is constant. So if the velocity is constant, or if the speed is constant, the final velocity, which is we are going to use v, must be equal to initial. So whenever the final velocity is equal to initial velocity, it's either the car is at rest or moving at constant speed. That's the other thing that you're supposed to know. If this is the case, then the acceleration must always be equal to 0. So there is no acceleration when the car is at rest or moving at constant velocity. Now, can we use this acceleration of 0 with the formula of acceleration to prove that the final velocity must be equal to 0? Must be equal to initial. So let's use this formula. We know that final velocity is equal to u plus at. Now we know that the acceleration is 0 times t. So we can just cancel this. We have seen that the initial must equal to final velocity. Now if this is the case, now how can we relate the movement of a constant speed with finding the total drag force or the force that is opposing this motion? Or the key is, what should be the value of the total drag force for a vehicle to move at a constant speed? So the key point is the force that is moving in this direction must be equal to this force, but in an opposite direction. So instead of writing 2000 newtons, we are going to put negative 2000 newtons. So the negative simply means that this drag force is in the opposite direction as the driving force. So to summarize our answer, we are saying whenever the drag force equals the driving force, then the resultant force must be equal to 0. When the resultant force is equal to 0, the acceleration must also be equal to 0. Then the velocity must be at constant. So that is what you're supposed to use when handling a question like this. Now let's move on to question B. If the driving force is increased, now we are told it's like the driver pressed on the accelerator, then the force now from 2000 increased to 3200 newtons. Find the resultant force on the car at this instant. So remember, the drag force is still negative 2000 newtons, but the driving force has increased to 3200 newtons. So for this time, we are expecting to have acceleration because the two forces are not equal. But before we do that, let's now look at this question. So how do you find the resultant force? So the resultant force is the net force. So we are finding the net force. So we'll say the driving force minus, or if what we can say, plus drag force. Then the driving force is this number, 3,200 newtons. Then we add the drag force is negative 2,000 newtons. So if we do some math here, we know that negative multiplied by positive will give us negative. So it's the same as you just have to subtract. So if we subtract 2,000 from 3,200, we get 1,200 newtons as our net force. So this is our answer for this question. Now we move on to Roman number 2. So for Roman number 2, this is where we are moving in the formula for second law of motion. So calculate the initial acceleration of the car. So the formula is force is equal to, and remember this should be net force is equal to mass multiplied by the acceleration. And this is the acceleration in the x-axis, but let's not focus on that. So to make acceleration the subject of formula, we divide by m, even here by m, so that if we cancel, we have the acceleration is equal to net force divided by the mass. So the net force is this number here. So we have 1,200 newtons. Then the acceleration is given in the first statement. So, I mean, not the acceleration, but the mass is given. So it's easy, 800 kilograms. So you divide by 800 kg, which is 1,200 divided by 800. I'm getting 1.5. So 1.5 Newton per kg is our acceleration, which is the SI units, the one that we know should be 1.5 meters per second squared as our final answer. So that's it for this video. Thanks for watching.